So this is the longest bridge we've done in terms of continuity. We've done about 18 bridges through North America, a couple of Class 1 railroad bridges. We've got one bridge in Australia, and always looking for other opportunities. This is I always refer to this as the $1 million photo. The Latvian bridge engineering tradition is that the engineer has to stand underneath the bridge when they load it. Of course, the railroads are insane about safety, so this was not the first load test. We'd actually run the train around the loop for a couple of days before we did the photo op here, and this was back in 2007. So this is the first proof of concept of an HCB bridge. And again, this is designed for a Cooper E100 with all the design criteria in the ARIMA code. We've done bridges on up to a 45-degree skew, and the benefits of HCB on a skewed bridge is that you don't have to have all the diaphragms that you have for a steel bridge, which simplifies your erection and the complexity of it. And also with precast beams, what happens is on a skew, when you drive a truck across it, it wants to load the beam underneath the wheel, and you get reflective cracking in the deck. So HCBs give you enough flexibility to avoid the reflective cracking, but at the same time, they've got enough torsional resistance that you don't need any intermediate diaphragms. And I'll talk more about that photo down the bottom later. We've done this is a pier that we did in Machias, Maine 11 years ago. This has survived a Category 4 hurricane and 11 very, very brutal winters on the oceanfront in Maine. This is all composite. It's composite-filled pipe piles. It's a 2-span HCB pile cap, and then it's HCB double T superstructure. This shows you another Class 1 railroad bridge. Again, rapid construction. This was, we got an 8-hour track outage to actually take out the old bridge and replace it with a new one. CP did this up in Fernie, British Columbia. We actually had it operational in about 7 hours. There's another one with BNSF out in Colorado. This is actually a 13-meter span. So this is the longest railroad bridge we've done to date. And I like to close up by just showing nothing's really changed. What you see is a burr wooden truss on the bottom left, back from the late 1700s, early 1800s. On the right is a cast iron railroad bridge in Tennessee that was built in 1860, and then you see an HCB above. It's exactly the same structural principles, just better and more efficient materials.